Okay, the final part we need is optimization. So the whole idea now is that we have access to two sectors, energy and high tech. And now we want to decide how much of our wealth should we put into energy and high tech to maximize the Sharpe ratio. So we have been given that the expected return of energy is 13%, the expected return of high tech is 14%, and energy has a standard deviation, a volatility of 22%, and high tech has a standard deviation of 28%. And the correlation between these two sectors are 0.54, so they are positively correlated. So when one of these sectors goes up, the other one is very likely to also do well at the same time. We have been given that the risk-free rate is 2%, and the initial weight is that we have 50-50. So we have half our wealth in energy and half our wealth in high tech. And since we want all of our wealth invested, these two should sum to 1. Okay? So the first thing we want to find out is the expected return. And then we might recall that we just take the weight on the first asset times the expected return of the first asset plus the weight on the second asset times the expected return of the second asset. And then we get the expected return of that portfolio. We can also do it within your algebra. So we just take a matrix multiplication for the weight vector times the mean vector. And they should yield the same result. And note now that this weight vector is already a row vector, so we can just multiply them directly without doing any transposes. Because this is a 1 by 2, this is a 2 by 1, which means they are already matched in dimensions. Then we can calculate the standard deviation. So we take the weight of the first asset squared times the variance of that asset. And note now that these are standard deviations, which means that we need to square them to get the variance. All right? Then we take the weight on the second asset squared times the variance of the second asset. And then we get some odd thing going on here. So we know that the last term should be 2 times the weight on first asset times the weight on the second asset times the covariance of asset 1 and asset 2. However, we do not have the covariance, we have the correlation. But we know that the correlation between asset A and B is the same thing as the covariance between A and B divided by the standard deviation of the A asset times the standard deviation of the B asset. So if we just multiply with the standard deviations on both sides, then we get that the covariance between asset A and B is the same thing as the standard deviation of A times the standard deviation of B times the correlation between these two assets. And this second part here is what is in this calculation. So it's 2 covariance terms, the weight on the first asset times the weight on the second asset times the standard deviation on the first asset times the standard deviation on the second asset times the correlation between these two assets. And then we get the standard deviation of this linear combination. So a 50-50 portfolio has an expected return of 13.7% plus minus 22% on average. Finally, we want to calculate the Sharpe ratio, which is just the excess returns divided by the volatility. So we take the expected return, remove the risk-free rate because it needs to be in excess of the risk-free rate, and divide with the volatility. And this tells us that for 1 unit of volatility, we expect to get 54% returns. Okay, so now we want to optimize this. So now we want to move these weights around such that the Sharpe ratio become as large as possible without breaking the restriction that is equal to 1. So in the first part, we added the solver. So we're going to use the solver now to run the optimization. So under data, we have solver, and then I need to set the objective function. And in this case, it's the Sharpe ratio. So I'm just going to click the Sharpe ratio because that's the cell we want to maximize. And then we need to decide which cells are we going to change values in. And we want to change the weights around such that the Sharpe ratio become as large as possible. We also have a constraint because we can't put infinite wealth into these assets. So we want to add a constraint that this cell, the sum of these weights, need to be equal to 1. It just says that we want to invest all our wealth into these two assets, nothing else. I push OK, and then we should get a restriction now. Okay, do we want anything else? Do we need another different optimization algorithm? No, just keep the standard. Push solve, and now the number should change around. So if I push OK, then we see now that the optimal portfolio has 72% in energy and 28% in high tech, which yields a Sharpe ratio of 0.55, slightly higher than we started with. So now we know that the optimal portfolio should be 72% in energy and 28% in high tech.